My name is Brian Mosque. For those of you who this may be your first time, I organized the meetup along with Corey Butler, who's in the back there. He's the co-organizer. And actually, raise your hand if this is your first time. Oh wow, quite a few people. Cool. So thanks for coming out, especially with this weird little 24-hour cold snap that came out of nowhere. Thanks a lot for coming. And so yeah, normally, for those of you who are new, this being the Bleeding Edge Web Meetup, we talk about all kinds of different things every month. It's different. And normally, I do a little sort of 20-minute thing, kind of a state of the web app technology world. I didn't have time to prepare that this time, so unfortunately, you're just gonna have to imagine me telling you about all this interesting web stuff that's going on. But next month, I'm sure we'll be back on track with that. But that saves us plenty of time for Ben Broussard, who's going to be talking web app security here in just a minute.
I got the URL.
Awesome.
I'll go ahead and type it in.
So before we get into that, though, I want to introduce Lance Vaughn from Cab Forward. They sponsored the food and drinks for tonight, so appreciate that. And I'm going to hand it over to him to tell us a little bit about what they are up to.
Yeah.
And I can type that in if you want.
Okay. Yeah. Well,
you got it.
So here's the URL. So anyone who wants to follow the live stream right now, if you want to follow the live stream right now, you go to capitalfactory.lifesize.com, and then from there, over on the right side is a link called main space. Click there, and theoretically, that's me. Click. That was kind of weird. All right, cool. Well, this isn't going to be very long, obviously. I really love following bleeding edge technology, so thank you to the founders for putting together a group like this. I just recently discovered this like a week ago, and I reached out to the founders and said, let me buy pizza. So I'm going to start coming, I'm going to start feeding ideas for speakers, etc. But nonetheless, real quickly, Cab Forward, we're a web and mobile development company. We're all based here in Austin. We're a relatively small shop, about 6 full-time employees and like 12 to 15 contractors. We started out as a Ruby on Rails shop, and we've just kind of grown into mobile. We've grown into JavaScript, we've grown into Node, and we've actually even partnered up with believe it or not, like a Microsoft shop so that we can go in together into a client site and theoretically just wipe out any issue they've got, right? Just a real quick shout out to my buddy James Wickett. James Wickett and I, who is a good friend of Ben, who you're about to meet, he and I are starting, or we're kind of latched onto this idea or movement that's going on that's called rugged software. And you're welcome to go to ruggedsoftware.org. And it was originally, the concept for the movement was originally founded by some of the OWASP founders, as I understand it. And the whole idea there is, there's a lot of ideas. It's not just building secure websites, right? But building websites that are reliable, scalable, maintainable, and it all comes back to the developer. Can I get a real quick show of hands? Are you guys software developers? Raise your hand if you're a software developer. Okay, cool. So anyway, this all goes back to the software developer and kind of accepting or stepping up to this higher level of commitment to excellence and commitment to quality, and agreeing that even though you're going to push a minimum viable product out to the net, understand that if it gets tech crunched and 1 million people start to hit it, it needs to be scalable, right? And to think about that possibility up front before you put it out there. So the idea, kind of like that Spider-Man effect, that with great power comes great responsibility. And software is eating the world, it truly is. And so it all comes down to this commitment to excellence before your fingers even touch the keyboard. Anyway, so I just challenge you to take a look at that ruggedsoftware.com or ruggedsoftware.org website. We're starting up, we just started up a WordPress site, we're starting up a podcast, we're going to start interviewing individuals who are outside of the software development industry So talk to manufacturers, construction, anyone who needs to build fault-tolerant systems and who needs to be able to own up to failure and to be transparent and collaborative with their clients, etc., and to learn, to find out if possibly there are other individuals in other industries doing things that we can glean from and apply to that software development craftsmanship, that software development art, if you will. So anyway, if you're interested in doing web and mobile development, please reach out to us at cab4.com. Enjoy the pizza, and Ben, come on up. Thank you.
Test. Okay. Hi everyone. I'm Ben. Can you all hear me through this? This good? All right. So I've got a presentation talking about the OWASP top 10. It's specifically application security. So to kind of set the stage, what we're talking about are websites, web pages, web servers. What we're not talking about is the TCP/IP stack, other network protocols, or physical security or Wi-Fi security. These are all important areas, but it's not what I do. What I do is specifically application security, hacking into websites, getting data, getting control of the system. And it's a great space to be in because there's a handful of network protocols, and there are many millions, tens of millions, hundreds of millions of web applications out there. So the number of experts looking at a particular application, extremely small. Number of experts looking at a particular protocol, very large. So there's a lot to find as an application security guy. So let's go ahead and dive right into it. What I'm going to go over specifically is the OWASP top 10. OWASP stands for Open Web Application Security Project. It's a great organization. It's basically where the minds of application security come together, dump their common knowledge, talk about what tools they use, what tools are good, that kind of stuff. The OWASP top 10 is specifically a rating of the top 10 most common and most dangerous web application flaws. So that's what we're going to talk about. A little bit about who I am. Most importantly, I'm the president of Hot Lava Obstacle Course. It's an indoor obstacle course. It's kind of my baby. Also, I am a web application security consultant for a security group called Denim Group. Right now, I'm doing some state work, doing some remediation, trying to patch the vulnerabilities that we found. Additionally, I run my own application security company, Medallion Security. But I have a background in various things, and this is kind of par for the course with application security folks. So breadth of knowledge is really important. Also a background in application development. That way you know what you're dealing with. So I have a BS in mathematics from UT. I studied cryptography mainly. I was originally a mainframe and web application programmer for UT Austin. That led me to OWASP involvement, which led to an AppSec career. If you're looking to get into application security, the Austin OWASP group is fantastic. It's one of the largest ones in the world. And Austin is actually kind of a hub of application security experts and knowledge. So great industry to get into. If you're looking to get into it, the monthly OWASP meetings, great place to start. But I get into other stuff too. Gymnastics, science, brains, various skills. I like Brazilian Jiu-Jitsu. It's just fun. And other stuff too. So what are these top 10? Some of them have more, I don't know, obfuscated names like insecure direct object reference. That's not as difficult as it sounds. It's really simple. It's when you have a URL and it has customer ID equals 002 and you make it 003 and you see somebody else's stuff. So the names can be a little bit, I don't know, intimidating, but the concepts usually aren't. But let's just jump right into it. So first one is injection. Injection, there are a number of different types of injection. The most common is SQL injection. This has a really kind of standard way that we see it, and then there are variants. Standard way that we see it is a program will take user input. Suppose that there's a search function. It's trying to find, let's say, users of a system. So you put in a username, and it brings you back your information. Well, the way that those SQL queries are often written in code, in scripting language like PHP or Java or any scripting language that you're using, it looks like this. You've got, let's see, can I have a mouse? Yeah, I have a mouse. That's not really useful. It looks like a select statement from a table where a column equals the user input. And what the programming language does is it takes the user input, it creates this query string, creates this string that has user input as part of the string, and then it runs that string. Now, all injection flaws look the same. What they look like is a line of code is created dynamically using user input, and then that dynamically generated line of code is executed. So, user input. If this user is an attacker, they can put their own input in there. They can potentially run their own code on your server. In this case, they can run their own SQL statements. So let's look at this particular example. We've got select star from table where a column equals, and then we kind of break out, we concatenate whatever the user input is, and then we concatenate on a semicolon. Standard SQL syntax. Now, if an attacker, instead of getting back one value, wants to get back all the values, then they can put in this cleverly crafted attacker's input here, which is X with a little single quote, and then space, or X equals X, missing a trailing single quote. So think about what that'll do. That will use that original single quote as the first single quote for the X. And now the select statement will look like select star from table where column equals X in single quotes, or X equals X. Well, X equals X is always true. X always equals X. And so the logical or of something and something that's true is always true. So what this select statement is going to turn into is a select star from table where column equals X or X equals X. It's going to select all of the records from that table because it's testing a condition that's always true. And depending on how the page is written, that all of those records will likely come back and be shown to the user. Usually there's just some iterating logic that says, okay, take all the results you got back, show them to the user. So that's a basic SQL injection. Now you can use that not only to change this particular query, but you can use that to union other tables in. You can use that in MS SQL to close out this query and start your own completely new query. That might say something like drop tables or insert a new user with administrative privileges. You can often use this to union together the users table and find usernames and passwords, which are, the passwords are often stored in plain text as opposed to hashed and salted, all that jazz. So that's kind of the basic SQL injection. You can get into more advanced SQL injections where you're not actually getting data back, but you can determine whether it was a valid query by the time it takes to get a response back. And then you can kind of, you can do some brute forcing and see, can I basically do test values and try to enumerate what tables there are, and then with that information, enumerate what columns there are with that information, try to get the actual data out of the database without it ever actually displaying. Just my inference based on the timing differences. And those timing differences are real. It's the difference between 1 second and 3 seconds. And that's big enough to write a program to just knock it out. You can also use the SQL keyword like, which is like a rudimentary regular expression engine. And so you can brute force in a lot faster way, more of binary search versus just standard brute force. Key space is a lot smaller. So that's kind of a deep dive into SQL injection right away. Who's with me? Who's feeling good? Okay, cool. There are other types of injections. Sometimes a system will package something up in XML on the back end and make a web services call, for instance. You can insert XML. You can basically, they all look the same. You close out the statement that your input is going into. You then have your own statement, and then you comment out the end. Or you use the end to complete your statement, one or the other. But so you can do this for XML. A great one is command injection, whenever they're taking user input and concatenating it into a string, like they all do, and then doing an eval statement. You can actually start running commands on the server's command line with the permissions of the web application. And so you think, okay, what's the real impact of doing this? And the answer is, what's the real impact of a user being able to run arbitrary SQL queries? What's the real impact of the user being able to run arbitrary command line commands? And it's basically anything those languages can do, which is, the command line stuff. You can basically just SSH into the machine once you have that. So it's pretty powerful. So for each of these top 10, I'll go through kind of the scenario, how it works, and then I'll go through why attackers do it and how to prevent it. So from a developer's point of view, okay, I understand, got it, that's a dangerous thing, now what? So why do attackers do this? They do it to get data. They do it to get control of the command line. They do it to run code on your system, whatever that code looks like, whether it's XML or OS commands or SQL queries. It's extremely powerful. When you find this as a tester, you feel really good because you got into the system, you got their data, you got what you're looking for. You can make a real case of, it was valuable to hire me to look into your system because there's this real hole here. How do you protect against it? Depends on your platform. But almost always there's some standard parameterized queries set up. And it basically looks like this. You build the query, you say, here's the query, and here are some placeholders. And then you say, okay, SQL engine, I want you to run this query, and here are the values for that placeholder. And it treats the input like data as opposed to like code. Instead of just concatenating it into a string where the interpreter won't know which parts are input and which parts are syntax of the language, you specifically say, here's the syntax and here's the input. And so parameterized queries, prepared statements, those are kind of the keywords to look for if you're looking for a solution in your particular platform or stack. And just don't take user input and execute it as part of a piece of code. That's the main way to stop all injection flaws. Thoughts, questions about injection before I go on? Cool. Okay, this is a big one. A lot of people have heard about actually, show of hands. Who has heard the phrase cross-site scripting before? Ah, nice. All right, another show of hands. Who in here is a developer? Okay. Anyone in here a security person?
What kind of security?
Any kind. Awesome. What kind of security?
Physical.
Physical.
Yeah, that's for physical security.
That's awesome. I have a lot of respect.
You're a bodyguard?
What?
Are you a bodyguard?
No.
No, you're more of a bank robber.
Look at me and tell that.
More of like a jewel thief, right?
Yeah.
Yeah. Okay.
Do the Capitol building and a bunch of other government sites.
Oh, cool. Yeah, that stuff's fun too. So cross-site scripting. Cross-site scripting is really kind of a antiquated name. It comes from a time when the cool websites out there had frames. You had a top frame, and you had a navigation side frame, and you had your main frame with your content. And back in the day, you could load whatever you wanted into those frames. You could load another site's page into one of those frames, and from the other frame, you could reach across and get data out. So if you had some user that was logged into their banking application, then you could load up that banking application's page in a frame, and your page in this other frame could reach across and pull out the data. Well, Netscape was the big browser at the time, and they were like, okay, we'll introduce something called the same origin policy, which has been expanded on and encompasses a number of things nowadays, but is a primary browser safeguard against a lot of different attacks, such as cross-site scripting, and later we'll see cross-site request forgery. And it basically says that code running on one domain, like google.com, or say evil.com, can't reach over, and it can make a request and it can pull data into its page, but it can't parse through that data. It can't pull out values from that data. So attackers got clever and they changed what cross-site scripting really meant. It's the same basic idea, but it works a lot different now. So how does it work? Well, it works in a dazzling array of ways. There are a bunch of different versions of cross-site scripting. They all do basically the same thing. It's kind of an injection flaw at heart. So let's take an example to start with. At the bottom here, we've got an example URL. It's a search field, and it's got a query string. Everything after the question mark there is the query string, which is just name-value pairs. And specifically, one name-value pair here, which is query equals, and then whatever the user input is. Now, in this particular instance, we're putting in a special tag here. We're putting in a script tag. We're using JavaScript document.location, which will redirect the user somewhere else. We're redirecting them to evil.com with a query string of cookie equals document.cookie. So you take this and you don't use it on yourself. This attack is to attack another user. So let's say I'm attacking Brian. And I'm going to craft this URL. I'm going to send him a link to it. I'm going to get him to click on it or go to it in some way. And when he goes there, he will, the page will look at the request that he's sending and it will say, okay, Brian's coming here. He is making a request for the search page. He's looking for this particular string, the script with the document.location redirect stuff. Okay, I'll serve up the results of that search request. And what it does is it takes the query string and it says, no results were found for script document.location, yada, 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 yada. And when Brian's browser gets that response and it looks, it tries to parse through the HTML code and build the page, it sees some script tags and says, okay, I know what to do with script tags. I'll run the JavaScript inside. So now I've crafted this URL. I've gotten Brian to go to it. And the page has returned the script tag that I cleverly put in there. So now I've run JavaScript on Brian's browser. That's the big reveal. I'm able to run JavaScript on Brian's browser through cross-site scripting holes. Anytime that the application takes user input and then displays it without any sort of validation on the page, that user input could be JavaScript. That's the main thing with cross-site scripting. It may be JavaScript. And if it's not sanitized, then it will execute on the browser, just like any other JavaScript. Now, this example.com search feature, maybe he doesn't even have any cookies for this. That's not really useful. But suppose instead this is a bank site. And I found a cross-site scripting hole on there. And I can get Brian to go there after he's already logged in. Then I can get his session cookie. I can masquerade as him. I can basically take any actions that JavaScript could take on his browser by creating this cleverly crafted URL and getting Brian to go there the cleverly crafted URL has the JavaScript that Brian's browser will then execute. So that can make requests, that can make AJAX requests, so it can be completely invisible. That can do redirections, that can build a little page that says you have to log in again, and it looks like a valid login page, and so he puts in his credentials, but they really go back to me instead. So basically, you can take control of the page that you found this injection flaw in, this cross-site scripting flaw in. Now there are two flavors of cross-site scripting. There's the reflected, which we talked about here, where you've got a cleverly crafted URL that has the JavaScript already in it. And maybe if you're clever, you can see that. You're like, I'm not going to click on that link. I know my internet security. But there's another type which is persistent. And this is an example where you might be attacking an administrator of an application. And you've got your own profile. You can put in your name, you can put in your address. And so in your name field, instead of putting in your name, you put in some JavaScript. And then when the administrator goes into the system and they pull up your record, it tries to show your name. But instead, it shows the script tag that executes the JavaScript on the administrator's browser. They didn't click on a special link. I had stored the attack in their database, and then at some other time, the victim, the administrator, made a request that pulled that JavaScript up into their page, in their browser, and it executes doing whatever they can do. So that's the flavor of JavaScript. It's misnamed, and it's kind of an injection flaw, but it's special. So why does an attacker do this? Usually to steal cookies. The cookie is the only thing that ties a valid user's browser to their session. So if you steal the cookie, then to the server, it looks like you are that valid user. Additionally, you can do kind of the phishing attacks and put the login page and get the credentials and trick them. But yeah, anything JavaScript can do on your browser, it can do on the victim's browser. The main way that you protect against this is the same thing you would do if you had a blog that you wanted to show HTML code examples on. You have to do something, otherwise the HTML code examples will just render as HTML, and the browser will execute that HTML. So the main way that you solve that is with what's called character encoding. There are special codes, usually something like &LT for less than, &LT semicolon. That's a special code, and when the browser sees that, it says, oh, I know what to do with this. I'll render a less than sign. And that's just this special encoding language that the browsers know how to render. So when you're building your page dynamically using your scripting language, instead of taking the user input and just displaying it, take the user input, entity encode things, and then display it. And now the script tag that the JavaScript is in won't execute as a script tag. It will just show up as text. The browser will render it as text instead of executing it because it has these entity codes instead of these special characters. That's the general solution. There are a bunch of side cases. OWASP has a fantastic cross-site scripting cheat sheet. If you're actually looking to solve this in your particular system, I would suggest going there for all the specific cases. The general rule is validate your input and entity encode your output. Thoughts about cross-site scripting? Questions?
Usually do that on the front end, the back end, both, or?
Yeah, you usually, so you'll get the request, it'll contain the user input. If you're storing that on a database, some people like to entity encode it at that point, but the real answer is whenever you are about to send the output back to the browser. So this will be in your .jsp file, this will be in your .php file on the server, and there are a bunch of really good frameworks that will help you with this that you just kind of plug in, and then all output that is kind of variables will be entity encoded. So yeah, it's on the server side.
And well, no, don't forget your single page app can do the same thing. So you should always encode.
Yeah, no, yeah, you can
always pay attention to
to
encoding. You have a single page app, somebody cross-site scripts it, you bind it into your page, you just did the same thing.
Exactly.
So
yeah, you don't need a big.
It's not just server. Sorry. Yeah, so that's in there and say you can definitely do that single page apps.
Let's see. Keep track of the time here. Yeah. Okay. Broken authentication and session management. So the login page, basically, and all the maintaining session throughout the logged in experience. There are a lot of issues here, and it's difficult to solve because a lot of systems have unique requirements. Sometimes there are multiple domains that they need to maintain login across. OAuth is usually a solution there. But basically, you've got this whole dance where you have to take user input of username and password, sometimes a second factor. You have to validate it, you have to give them a cookie, you have to store some stuff on the server, and you have to maintain this, check their cookie, is it valid? That whole dance is complicated, and so we often see issues with authentication session management. There are a lot of issues. I'm just going to scan my bio. So why these are useful for attackers is because you can masquerade as somebody. You can get their credentials potentially, you can get their session cookie, and where you don't even need their credentials, and you can see their data. You can take actions as them. So if it's an administrator, that's awesome. You've got really a lot of privilege, a lot of authorizations in this system. You can do a lot of things. If they're just a user, maybe they have a social security number, a credit card number, some other special information stored on their particular profile that you can get into and get out. It's difficult to do this well. So you kind of use a standard library, you follow you make some type of good cryptographic cookie. You need SSL everywhere at the login page and after. There are a number of other things, but this is just kind of a major area of attack. One aspect of this that I'll go into just because it's kind of a fun story is lockout, account lockout. So I think we've all had this happen to us. You forget your password, you type it the wrong one in 3 times, 5 times, 10 times, whatever. You get locked out, you get that page that says contact the help desk or reset your password or something like that. And that seems like a good feature. You keep people from brute forcing your credentials, you keep attackers from logging in or trying to guess passwords, things like that. But back in the day, on eBay, you would be able to bid on an item, and then you'd be able to see the usernames of people who are bidding against you. And so you could try to log in as them. And you could do it incorrectly 3 or 5 times, and now all your competition was locked out of the system. And it takes them a little while to, reset their password and get back in, by which time the bidding is done and you've won the thing. So yeah, that's one example of an issue with session management. Since then, you no longer see the username of the individual, or you see their profile name. So, all right, here's that difficult sounding one, insecure direct object reference. But it's really this simple. You have a shopping cart page and it has cart ID equals 413, Judith 412, and you see someone else's shopping cart. Maybe they have a receipt attached to that, so you can see maybe some payment information, things like that. I think it was Citibank back in the day actually had account equals in the URL, and you could increment it. It was just sequentially numbered. You could increment it and see somebody else's account. So this is really common, and when we see this, it's indicative of kind of a complete lack of understanding of security, application security concepts. Because this basically says, we just expect that the user is going to give us the right information every time. And with that expectation, there's usually cross-site scripting holes associated with that. There's usually SQL injection flaws associated with that. This is kind of the bell cow of it. This is the thing that says there's a lot going on here. Even if I can only get some information through incrementing this, I can get a lot of information elsewhere. And this is something that we still see pretty regularly. So attackers can access other users' sensitive data, maybe take actions as those other users. And the main thing here is that the system is not checking authentication or authorization. The system is not checking authorization. It's not checking to see, is this user valid for this account number? Is this user valid for this card ID? And so that's basically a whole area of security authorization that doesn't exist in the system. Cross-site request forgery. This is probably the most complex to understand and one of the simplest to execute. So understanding this pulls in a lot of things. There are, it's an attack from an attacker against a user who's logged into a system. It's really an attack against the system trying to take actions. It involves the same origin policy that exists in the browsers. It involves cookies and how login is maintained. It involves a lot of moving pieces. The first time I learned about cross-site request forgery, I argued with the guy who's teaching me for about half an hour that it didn't exist. And I was wrong. But it's really difficult to understand. So I'll give an overview of how it works, and if it doesn't seem like it actually works, or like it's a real thing, don't worry. It's just cross-site request forgery. It's really, really difficult to pick up the first time. But it's extremely easy and extremely common. It's also extremely targeted. This isn't something that you blanket the internet with and you see, which sites are vulnerable. This is something where you're a valid user of the site and you know there are other users as well. This might be a banking application or a direct deposit application or something like that. And you think, if I could just get that user to change their settings or to change their account number, then all of their direct deposit checks would go to my account instead. This is kind of the use case of cross-site request forgery. You're trying to get a user, a valid user of the system, to change what they can change. So let's do it. Okay. So as an attacker, here's what I do. First, I'm a valid user of the system. So I go to the page that I want some other user to update on their session. And I update it. I don't necessarily have to send that request to the server, but I need to know what all the form fields are, and I need to be able to submit a valid form. So usually how you do that, you try to submit it. You have an HTTP proxy, which catches the traffic when it comes off your browser but before it goes to the server, and you scrape out all the form fields. You then create a little web page that has a form in it with the form fields that you just scraped out, and probably some sort of auto-submitting JavaScript, document.forms 0.submit or something like that. All right, so now you've got your attack. You put that up on a server, evil.com. So I'm the attacker. I'm also a valid user of the system. I've gone into the form that I'm trying to attack. I've basically duplicated that form and put it up on evil.com. Now, I get somebody who I know is a valid user of the system and who I know is going to be logged in when I get them to go to evil.com to my duplicated form that I created. Okay, you can see it's starting to get a little fuzzy here. So there are some ways to do that. We'll talk about those in a minute. But suppose, just hit the I believe button for now. Suppose that I've got some user, maybe an administrator, maybe just another user of the system. I know they're logged on. They use the system 8 hours a day, every day, because they work there. I send them a link, gets them to go to evil.com. All right, so they're logged into the system. They could go and submit the form that I'm trying to get them to submit, say the direct deposit form, to change their account number over to my account. They could go in there and do that themselves validly right now. They're logged in, they can do it. They go to evil.com. Evil.com has the duplicated form. It posts to the same place that the valid form does. And so when they go to evil.com, the form automatically posts with the data that I want to be in there as the attacker. Posts to the right place. The server gets that. It says, okay, this looks like a valid form. It's got all the right fields. It's got everything it should have in there. And, oh, look at the cookie here. It shows me that it's the valid user. They're logged in. Everything looks good to me. So from the server's point of view, it's got the right user to make the request. All the fields look correct. And so it performs the action. It updates that user's account information to the attacker's account information. It's right before payroll goes out. And backgrounds check, I guess no longer background, goes over to the attacker instead of to the individual it's supposed to go to. There's a lot of moving pieces here. And there's, again, the overview. Attacker figures out what the correct form fields are, puts it up on evil.com, gets the logged in user to go there. The form posts to the same place it would post to through normal channels. The server sees all the right stuff, performs the action on the user's behalf, but does what the attacker wants. That's cross-site request forgery in a nutshell. Thoughts on that before I move forward? Questions?
Probably a pretty dumb question, but so is it, would like the URL show up as evil.com versus anonymous?
It would.
So
Yeah.
people are not paying attention to that.
Yeah, I mean, maybe it's, evil.wordpress.com, or, maybe it doesn't look too bad. Maybe it's not actually evil.com so much as, Bitly or something.
How is the evil.com graphical cookie thing?
It doesn't. So this is one of the things that's part of all of this. It's how browsers and servers maintain session. When you log into, let's say directdeposit.com is our app that we're talking about. You log into directdeposit.com. Your browser gets back a cookie set for directdeposit.com. Now, every request that your browser makes to directdeposit.com sends that cookie along. And that's how the server knows who you are and maintains that session throughout your login experience. Now, when the victim, the user, goes to evil.com and the form is posted to the correct place, that correct place is in directdeposit.com. So the browser says, hey, I'm making a request to directdeposit.com. I'll send along my session cookie. And so that's how the session cookie gets sent. Evil.com has no access to it. The same origin policy is in place to prevent that very access. Good question.
Could the form fields be hidden, or is it like very obvious that you're trying to duplicate?
Yeah, so an attacker can put up a picture of a cat, make everything else hidden. It's very important to put up a picture of a cat. But yeah, this can be done entirely invisibly. It can be done with an AJAX request, so it doesn't even redirect the user's browser. It's all done asynchronously behind the scenes. The user, yeah, you can make it so the user has no idea that this is happening. Questions? Any other thoughts? Sounds like you guys actually are picking this up a lot better than I did my first time, which is good. So let's talk about why attackers do this. Attackers do this because they can force valid users, often administrators, to take actions in the system. These actions can be password update. These actions can be change your direct deposit information. These actions can be transfer some funds from your account to my account. These actions can be anything, any action that a user in the system could do. So what can the application do? That's its scope. How do you protect against this? There's a caveat, which is if there's any cross-site scripting in your domain, it's almost impossible to protect against this. Cross-site scripting can run JavaScript in that domain. It can grab the session cookie. It can basically make any requests, parse through data, do anything. But assuming there's no cross-site scripting in your domain, the way that you protect against this is you put something in the form that the attacker can't figure out what the valid user's version of it. You put a token in there. This token is tied to the user session. It's difficult to guess. And now, when the attacker's trying to do this, they're going to grab the form. They're going to create this evil.com duplicated form page. But there's a field they're not going to be able to get right, which is this security token, this cross-site request forgery token field. They can't get it right because they're not able to get, I'm always doing these attacks to you, Brian. They're not able to get Brian's version of that token. They can get their own version, but the token's tied to the session. So they can only make requests using that token that they get for their session. They can't use their token for Brian's session. And so that's it. Basically make it so that only a valid user has enough information to make a valid request. The attacker doesn't have that special. Yeah?
So that's like, I think it's called the nuance in WordPress, or is that?
Yeah. So there's this word nonce, which is really just a combination of number used once. Once. Nonce, yeah. And it's a cryptographic thing. A nonce is a special type of token because it's only used once, and you generate a new one each time. Really, it doesn't matter. You can use a nonce where you generate a new one each time, or you can use a token that's tied to the session and use it throughout, just as long as you don't divulge it off-site to other things. So yeah, it's often called a nonce because originally that was kind of the solution. Use this cryptographic nonce. Yeah, use this token that's tied to the session. Only a valid user gets it in the form. So when they submit that form, it has their special token. The attacker can't get access to that. So the attacker can never craft a valid form for the user. Security misconfiguration. This is just kind of a catch-all. Default accounts in the system. This used to be huge. Every standard installation of WordPress had a default account. You could just go in with admin, and this was something you'd find everywhere. A lot of systems are a lot better about that now. A lack of SSL helps people who can read information going through the air, in coffee shops, unsecured networks, things like that. There are other insecure features. PHP has this great tag, this include tag, where you can pull in code from other sites into your, you basically make a request on the server to go get that code, and then you build your page dynamically with that. So if that's user input control, then you can make it a request to evil.com and pull in evil.com's code. It's usually kind of a cross-site scripting attack. And then there are just, old versions of things that have known vulnerabilities, this kind of stuff. It's a very broad category. Often, security misconfigurations can lead to things like SSH access into the machine. You can start running commands. You find a file upload flaw or something like that based on an old version of PHP Blackboard, and you're able to upload a PHP script, and then you're able to go to that page and get the server to execute that script. Now you're running PHP code on the server, and you can basically use that as a SSH shell to run command line commands. And that's kind of the name of the game here. How do you protect against that? You have a good patch process in place. You have procedures where you actually review your setup to see if you're using outdated versions of things. This is kind of boring, but it's the procedural stuff where you always, you're checking to make sure you're up to date on your patch levels, that kind of stuff. Insecure cryptographic storage is still extremely common. This is usually just passwords stored in plain text. Usually the user credentials for a web application will be stored in a SQL database, and it'll have a couple columns, username, password. If you can find a SQL injection vulnerability, then you can usually union your area with the user table and pull out usernames and passwords. That's not how, that's not a very secure way to store passwords. The more secure way is you hash the password, because you never really need to know the password. You just need to be able to verify that somebody gave you the right password. Hash is a special cryptographic thing. Let's skip over that because it's in depth and cryptography is kind of involved. But as an overview, you've got encryption, where you encrypt something and you can decrypt. And that's for data that you want to keep secure while it's in transit. And then you've got hashing, which is taking input, munging it up so you can never decrypt it. There's no decryption of hashing. Why would you do that? Well, because you could take that input again, munge it up, and get that hash value and compare. And so when somebody sets up a username and password, you take their password, you hash it, and you get this thing you can never get the password back from. You store that on your system. Somebody takes your, someone finds a SQL injection flaw, takes your list of usernames and passwords. They haven't really taken your passwords, they've taken hashes of it. Now there are some other aspects, like you should hash it concatenated with a salt value that you store in there as well. And that's just so people can't use a lookup table, find collisions with the hash. It gets kind of involved.
You concatenate the salt and then hash it?
Yeah, you concatenate the salt with the password. You hash that, you store the username, the password, and the salt value. Somebody comes into the system again, they put in the username and the password, validate the usernames match, take their password, concatenate the salt, hash it, validate that matches the hash that you have in the system. And that way you can validate the password without storing the password. That's the magic of hashes. Attackers love this. They get sensitive information that should be encrypted or hashed. You protect against this by using encryption or hashing and enforcing proper key management. If your keys are, I don't know, in some file that's in a web accessible directory or something, that's not good key management. So that is something we find. Failure to restrict URL access is very common. There are kind of two flavors of this. One is a system built where the developers think, okay, everybody has to go through the login page and then they'll get redirected to the logged in area. And they don't actually check authorization in the logged in area. They just check the correct username and password on the way there. So if you can navigate directly to that logged in area, you don't even need a username and password. That's actually rather common and kind of easy to find, especially with the help of this amazing thing called Google, which kind of does that work for you. The other area of this we find is with images or files, PDF files, that kind of stuff stored on the server, because requests for these don't go to PHP files. Requests for an image go directly to the server, and it says, get me the file at this location on your server. And the server says, okay, I'll do that. And so if you have authentication checking in every single page, you're still not going to be checking authentication when the request is made for an image or for a PDF file or some other file that's not a scripting language file, like a PHP file. In PHP files, you're going to be checking authentication every time, but you don't hit a PHP file with a request for an image. So that's kind of where this other area of failure to restrict URL access comes from. This is really useful for a lot of systems that do a lot of imaging. So where we've found really useful attacks in this area is systems that will take an application for health insurance or something like that that has social security numbers on it, personally identifiable information. they'll image that, they'll scan it, and they'll store the images in some internet accessible directory. And so if you can find where that is, and especially if they have directory listing turned on, then you can just basically see all of the images. You can just click on each one, look at it, write down the social security number, or use some sort of text recognition, and get sensitive data in that way. So that's a great use of this for an attacker. How do you protect against this? You have a kind of framework-wide authentication system that takes into account all requests that come in, not just requests to individual pages. That's kind of the broad answer. It depends on your platform, other than that. Insufficient transport layer protection, I'll just kind of skip over this. A lot of times there will be pages that are served up over HTTP and HTTPS. One's over HTTP, if anyone's on the network, sniffing the traffic, can see all the data going back and forth. So use SSL if there's sensitive data going back and forth is the key there. And then unvalidated redirects and forwards. This is a useful thing more for phishing than for like getting data out of the server. This is a way to attack a user through a web page. A web page will have it'll have a user-controlled input that will be some resource. So it'll include, or it'll make a request for some image or something like that. It will, you'll see this a lot in login pages. Usually, you're logged into a system, you don't do anything for a while, you try to take an action, and you get logged out, and you have to log back in. But when you get logged back in, you go right to the place you were. Well, that information can be passed around in a couple of ways. And one way it can be passed around is through basically form fields. It can be passed through the browser each time. If that's the case, then your login page has a user input, which is basically, where do I go once I'm logged on? So you make that be evil.com. An attacker makes that evil.com, sends a user logs into their system, it shoots them right over to evil.com. Evil.com has a page that looks just like the login page of their system. Try to log in again, now the attacker has the credentials. So that kind of redirect, user input used to redirect the user is rather prevalent and can be used primarily for phishing attacks. The answer here is when you are taking that user input, validate where it's going. Don't take in a full path, take in a part of a path. Take in just like a directory and an actual location. Don't take in HTTPS : //. If it has that in it, it's probably not going to one of your pages. It's probably going somewhere else offsite. A lot of times you can say, okay, well from here, there's really just these 3 pages that you should be redirected to. So make sure whatever that user input is just one of those pages. Additionally, you don't usually have to pass that information through the browser. You can put it in a session. You can put it in their session on the server, and their session cookie or whatever their key is that ties to that will keep that information present for them. So that's kind of the last thing here. General questions now? Thoughts about any of these? We had injection, SQL injection, command injection. Yes?
I wanted to come back to hashing and actually ask you what hash method you prefer or recommend for databases.
Anything in the SHA-2 family of hash algorithms.
Okay.
Is the current recommendation by the security community.
Where does bcrypt fit into that?
I don't know what bcrypt is. So my background is in cryptography, and I will say that hashing algorithms are not good. So first, hashing algorithms, Md4 and Md5. The way they work is you take the string, you break it up into pieces, you move those pieces around, you do simple things like, you've got basically a bit string here. You add 7 to it. You add 13 to this one. You add 13 to this one. You add 7 to this one. And then you mix them up. And then you do that again. And then you mix them up and you do that again. You do that like 4 or 5 times. And then you've got a hash. Well, that's not really a very good way to, that's not, the whole idea of a hash function is to be one way. So that you can't take a hash and go backwards to the original string. You do 4 or 5 iterations of a couple things. It's not really unreversible in the grand scheme of things. MD5 did it 7 times instead of 4. SHA-1 was another series of mix it up, add a couple things to it, mix it up, add a couple things to it. It did it a few more times. It gave you a larger number. It was harder to find collisions. It was harder to go backwards. It was harder to reduce the key space. But they're all, they basically said, oh, that one's not working anymore. Let's do more of it. And so they all have kind of the same basic style. I don't think any of them, but the standard recommendation is to use the SHA-2 family of algorithms. Yes?
A question from a web development framework perspective. Clearly, they're all different beasts. You've got server-side frameworks, client-side frameworks, and in your opinion, or from what you hear, what are some of the better or more secure frameworks, right, that cover potentially all of these?
Right.
And then also, what are possibly some of the worst that we should steer clear of? Right.
That's a good question. So some people will come up here and they'll say, the answer to these problems is that we need cooperation between public sector and private sector, and so on and so forth. We need some real smart minds thinking about this. I disagree entirely. I think the solution to this is technology. I think the solution is good frameworks that by default have this security built in. So you sit down, you want to write an application, you don't have to think about every single little thing you have to do in order to add the security in. You have to think about areas where you have to take the security out for special functionality that you can make a case is still secure. So then what you have is a bunch of developers using software, or using technologies to build applications that are by default a lot more secure. Ruby on Rails does a great job. Django, Python, Django, Stack does a great job. PHP, usually not as good, but some of the frameworks are better than others. I couldn't tell you exactly which one's the best. And anytime you see Perl, there's basically not a framework. So as an attacker, you look for CGI bend directories because you can usually find some good command injection stuff there. You can usually find a lack of authentication. You can usually find that stuff is outside of any framework that's being used. So yes, frameworks are awesome. The newer ones are generally better, and the more popular they are, the more scrutiny they're getting.
How about Node?
Node.js, I haven't actually looked at how Node.js handles the various things. So I can't.
Node's really more of a language, so not a framework. So
It does run a publicly exposed server.
yeah, it does, but it's not really a framework that enforces. I mean, it listens on a port and gives you the ability to map that into whatever you want. So like, Node itself isn't really a framework. You
Does Node
plug
have
in
like
different authentication modules to Express or different places, right? But like,
Does Node have like a scripting language? I guess what I mean is like a tag library language.
Node is an we were just talking about this actually. Node is an ecosystem that lets you pull in whatever libraries you want, and so the idea that there's like a tag library kind of doesn't really sort of make sense there, like in the PHP sense of the word. It's JavaScript, and you can pull in what you want. So in that way, yeah, it's super dangerous, and in that way, it's also can be super liberating. And at the end of the day, you can take the most secure framework and not sanitize your parameters and end up in and think you're secure and end up in the worst spot. You know, so you know.
So
I didn't really answer the question other than it's not really Node, it's kind of a decision you make on top of it, right?
So when you say Node, you're talking about the language and the server, like NPM is the server and...
Well, no, NPM is a package manager.
Oh, it's a package.
Node is just server-side JavaScript, that's all. It has bindings for the OS and you can do file system.
I think one thing that's important in Node is build your own server. You know, it's not like you're going out using Apache or IIS. You're writing your own website. So if you don't include that, or if you don't use a module, or there are a lot of frameworks out there, but yeah, you just got to go through them to figure out which one is right for your needs and whether or not it's secure enough. It's kind of a question of what the author do.
Right. I would look at specifically. I would look at how it handles request parameters, and that wouldn't be Node, for instance. That would be the module that does your routing, right? Are you sanitizing your parameters, right? And checking them for type and other things, right? Right. So
you know you're looking up, you know, ID equals, and you know that that's a number, right? You should never just pass a string to your data storage, right? Like that's so anything that sanitizes parameters is good for you.
So yeah, there are likely a lot of things that by default the modules we would pull in would sanitize the inputs in such a way as to entity encode them when they're headed out. There's undoubtedly something that kind of sits on top of.
There's definitely there are a bunch of modules that you just pull in to use for sanitization.
Right.
If you use Express, which is a it's commonly used web server essentially. It's like apparently it's based off of Sinatra, which is a Ruby framework. You know, it'll have middleware that addresses CSRF.
Right.
So you just say use CSRF, and then whenever you have put a form where you need to post to, it automatically puts in a type.
So from an individual application standpoint, it sounds like there are a lot of standard frameworks that you can pull in and use for Node.js. And that means that there's a lot of scrutiny on those, they're commonly used. That's a great way to develop a particular application. From an enterprise standpoint, where you have a dozen to a couple hundred applications and a whole bunch of developers, you run the risk of basically giving them the power to not only make it quickly, easily, well, but also wrong, and introduce those flaws. So that's kind of the trade-off. It depends on how big your shop is.
Thank you.
Yes?
Is there a website or a testing tool to check whether your website handle all of this, at least this basic security issues?
Yes, so there are kind of three things there. One, any of this information you can find through OWASP. OWASP has a fantastic wiki. It has great cheat sheets for how to test things, how to secure things, lots of great information. It's where all the minds internationally get together and put their cutting edge and base of common knowledge. Fantastic resource. As far as testing, learning this stuff, getting your hands dirty, there are two things. One is an OWASP, I don't want to say project, which is called the Broken Web Apps Project. It's a virtual machine. It's a server. You load up this virtual machine in VMware or in VirtualBox, and it runs a server on your machine. It gives you an IP address to connect a browser to, and it has maybe 20 different applications that you can attack. You can actually attack. It's running on your machine. No legality here, just something that you can just play with, tinker with. When running that, and actually doing the attacking, an attacker's bread and butter, a tester's bread and butter is called an HTTP proxy. It sits between your browser and the server. It sits on your machine right here. After the HTTP request leaves the browser, it hits this proxy. You can see all the form fields, all the cookies, all the headers, all the information that's going to the server. You can also see all the information that's coming back from the server, how they're setting the values of their cookies, whether they're using an HTTP only flag, which means that JavaScript can't access the cookie. And that's what an attacker uses, or a tester uses. They use this proxy to see what's going on behind the scenes and to see what they can change. They might see a price value leaving the browser. They might see the cookies that are being set are very guessable. So they might guess somebody else's cookie in order to get it onto a different session. So that's kind of, those are the three things. OWASP is where you learn everything. OWASP has broken web apps, virtual machine server, and as far as HTTP proxies go, my favorite one is called Burp, as in a belch that you would issue forth. Burp proxy, B-U-R-P. It's got fantastic functionality. There's a free version and paid version. The free version has all the functionality you would need except in extreme cases. And the other proxy that's really good is actually another OWASP product or project called Zap. Z-Attack Proxy, Zap. Which is pretty good. But Burp is top of the line. Cool.
Have you ever used Backtrack Linux?
Yeah, Backtrack is cool.
Yeah, it is.
Backtrack is basically a default installation of Linux that has a bunch of attack tools loaded up on it. Backtrack is usually used more for the application side, or not application, more the network side, server side, Wi-Fi side of security. It's got by default like air crack and certain weak Wi-Fi protocol crackers that'll let you get onto somebody else's network. It's got a lot of the tools that you would use in more of a network level assessment or attack. So I don't use Backtrack in my everyday work.
That has tools to assist the in and out traffic too, doesn't it?
It probably does, yeah. It almost certainly does. Some people do use Backtrack, but in the application world, we usually don't use Backtrack. Other questions? I'll end it there. The contact info. You can also talk with me after. And that's it.
Cool. Thanks. So I just wanted to review one of your slides real quick. I saw something right in here that you kind of skipped over. See, B-Boy.
Oh, yeah. I used to be a breakdancer.
So I was waiting for the demo. Never came. I thought, well, he skipped over it, but maybe he's going to come back to it at the end. But never came up again, so I was curious about that. But yeah, thanks for the talk, man. It's awesome. And of course, thanks to the Cap Forward guys. And one announcement that I mentioned on the Meetup thing, but I'll just mention it again, is normally at least a couple of us will walk across the street and have a beer over at Buffalo Billiards and carry on conversation. So if anyone's interested in that, feel free. And I also normally open it up to if anyone has any announcements or just any comments or anything you want to make. A lot of times if someone's hiring or if someone's looking for a job, this would be a good time to announce it. So does anyone have anything?
I'd be interested to know maybe what everyone would like to talk about in terms of topics. I want to go out and kind of help cultivate some speakers. So I know the primary focus is web technologies, right? Which basically you can kind of extrapolate from that to say anything that we do with JavaScript, anything mobile. Does anybody have any like specific specific ideas of what you might want to talk about or what you're interested in.
Yeah, and I'll repeat that just in case for the one person on the internet who might be watching the camera, ceiling mounted there. So there's more of a request for comment, I guess. If anyone has any ideas for future meetup topics, and that's actually a good point that I would make as well, because we're always on the lookout for people who are willing to present and so forth. Then actually, I didn't find him. He came through the meetup group and sort of volunteered, and I love it when people do that. So if you have a particular area of interest or expertise yourself, or if you just have a topic you'd like to hear, definitely let us know. So if you happen to have something right on the top of your head, feel free to shout it out. Otherwise, come and talk to me afterwards, or come talk to Lance or Corey, or send us an email or whatever. So does anyone have any other questions, or is anyone looking for a job or looking to hire anyone, anything like that? Cool. Well, like I said, we'll walk over to Buffalo Billiards. At least I will, if no one else. So if you're interested, feel free. And thanks for coming out. Appreciate it.